Okay, so now we're going to take a look at graphing function tables. So when graphing equations, there are many different ways to graph an equation. We're going to look at how to graph equations using function tables. So the first step is to complete the table and determine the coordinates. So this is the part where you fill out the table. You take the x you're given, substitute it, do the math, and get a y. Or you pick your own x, substitute, do the math, get a y. So first step is actually complete the table. Second thing you're going to do is once you complete the table, you get your points, your x and y coordinates, and you plot those points. And the third thing you do is connect those points to make a line. Now remember, with equations, they create solid lines. Okay, the points we have on the table are just the ones we put in the table. There are many, many points in between all of those. So once you're finished with the points you get, you connect the dots to make a line. Let's just jump in and get started. So sometimes when you're asked to graph using a table, you don't have a lot of room for your work. So what we're going to do is I see my equation up top and I see the x values that I have to use, but I don't have enough room to actually do my work here. So underneath, I'm actually just going to make my own table. Now, one thing to note, this equation starts with an f that has an x in parentheses. That would be called f of x is the way that it's said when you look at this. It actually means the same thing as y. It's the function of x, f of x. The function of x is equal to y. You just need to know that they're interchangeable. It's talking about the same thing. So they give me x's. My first x is -5. We'll substitute into the equation. Remember, the x is getting replaced. So this negative sign on the outside stays on the outside. And instead of an x, I'm going to put -5. Now this is the hardest it's going to get. Really won't get much harder than this today. So I wanted to include this in the example. But be careful with this negative sign. You can imagine it like -1x. -1 times -5. Okay, so just be careful with the notation. If I have a negative times a negative, imagine this is -1. -1 times -5 is 5. 5 plus 3 is 8. So my y value will be 8. Next up is -3. Can follow my same pattern that I did in -5, and I have -1 times -3 plus 3. -1 times -3 is 3. 3 plus 3 is 6. X equals -1. Follow my same pattern when substituting. I get negative times x. -1 times -1 is 1 plus 3. I get 4. And then go ahead, I'm out of room, but you go ahead and complete the rest of that table on your own. Hit pause, complete that table, and then we'll see what you get. You should have gotten 2 when x equals 1, y equals 2. And when x equals 3, y equals 0. So now we're going to plot our points. The top number is my x value, the bottom is my y value. Now one thing to note on your graph here, everything doesn't go by ones. If you notice, my y-axis goes by twos. So be careful. So my first ordered pair is negative 5, 8. Negative 5, 8. And if you want to take up a little more room, you can always write your ordered pairs, or you can just graph them from the table. Then we have negative 3, 6. Negative 1, 4. 1, 2. 0, 3. Connect your points. And it should make a line. Now you do want to include arrows at the end of your line because this is going to go on forever. So remember, we connect these points because just because it's not on our table doesn't mean it's there. There are actually ordered pairs in between along this entire line. So many ordered pairs that together they make a line. If I gave you x equaled negative 2, there would be a point right here that would match. Okay. X is 0, there would be a point right here that matches. You only have to plot the points you got from the table, but when you connect them, you make a line. The other thing to note, if you happen to have a point out on the side somewhere that doesn't seem to fit, there's a problem. This should be a straight line. There should be no curves, no bends, no twists. It should be a perfectly straight line. If you can't get a perfectly straight line, sorry about that. If you can't get a perfectly straight line, there's a problem with your ordered pairs. Usually you'll see, for example, you'll see things going in a pattern, and then all of a sudden there's one out to the side. Well, if these all follow a pattern here, and then this guy's out in La La Land, this one may be the problem. Double check your math. Double check that you plotted the point right. Those are the two things that happen. Either your math is wrong or you plotted it wrong. Let's look at another. So 3x minus 6. Again, let's go ahead and make a table so we can do the work. Do not try to calculate all this in your head. It's the number one reason for mistakes, doing too much in your head. Take a second and make a table. My first x coordinate is 0. Substitute the x with a 0. I get 3 minus 6, negative 3. When x is 2, 3 times 2 minus 6. 6 minus 6 is 0. Now, when you're doing your subtraction, if you adding the opposite will absolutely be helpful to you. At this point, I'm leaving it up to you to do that. Hopefully, you know that makes life a little bit easier. When x is 3, I get 9 minus 6, which is positive 3. I want you to go ahead and complete your table with x equals 4 and x equals 5. Hit pause and then come back when you're ready. You should have gotten 6 when x is 4 and 9 when x is 5. Let's go ahead and plot our points. 0, negative 3. Remember, my y-axis is a little bit different. My scale is by 3s. 2, 0. 3, 3. Oh, hold on. Something's off here.